orbital overlap, and hybridization. So at the end of this lesson, you should be able to draw and describe the formation of sigma and pi bond from orbital overlapping. Okay, so orbital overlap based on the valence bond theory. So valence bond theory states that a covalent bond formed when orbital of two atoms overlap and the overlap region occupied by a pair of electrons. Okay, so for example, it's like this. So take example HF bond. So remember fluorine has obey octet rule. Okay, obey octet rule. So original fluorine, hydrogen has 1 electron, fluorine has 7 electron. Okay, 7 electron. So this electron is not paired yet. So this is the electron that I draw as p orbital without pairing electron. So fluorine from period 2. So fluorine from period 2, so the valence is 2p. Okay, hydrogen from period 1. So 1 only has 1s1, so this is hydrogen. Okay, so fluorine will bring the unpaired electron here. This is unpaired electron. And hydrogen will bring the unpaired electron here. So these two unpaired electrons will overlap each other. So like this. Okay, so this is 2p shape. This is spherical shape for hydrogen. So I label here, this is hydrogen, this is fluorine. Okay, they will overlap each other. And this overlapping region will have both of the electron spin up, spin down as pair. And this pair we represent as the bond. Okay, the arrow is quite messy, but I hope you see the connection there. Okay, so the sigma bond occur when there are one bonding interaction that resulting from the overlapping of two orbitals, and the orbital overlap must be head to head, or we call it as end to end. Okay, head to head like this. So this is head overlap with head. Okay, this case for H2. Okay, head to head, or this is example like HF before. Okay, so HF head overlap with N. Okay, so the N, this is N, this is head. So head to N, or you can end to end. So this is maybe chlorine. Okay, Cl, 3p. So Cl2 bonded to each other become Cl2, and the overlapping is between N to N. Okay, N to N. Okay, and this overlapping contain pair of electron. Okay, what about pi bond? Pi bond is different from sigma bond. So pi bond usually in the double bond or triple bond. So pi bond in double bond or triple bond, we will see later. They will have two regions of electron density, above and below, because the overlapping is side to side. So this is where the region of electron, so above and bottom. Okay, so one pi bond will hold two electrons that move through both regions of the bond, and pi bond has restricted rotation. Okay, so pi bond occur in double or triple bond. Okay, so this is how you represent the pi bond, and this is the symbol for pi bond. Okay, next one. If you have double bond, for example CO2. Okay, CO2, let's take one side. So C double bond O. The first bond that we made is sigma bond. So meaning that oxygen and carbon will overlap head to head like sigma bond or end to end. Okay, in sigma bond. But another one bond will be pi bond where oxygen and carbon will bond side to side. Okay, so sigma bond will bond head to head or end to end. Pi bond side by side. Next one, triple bond. So example in N2. So N2 and triple bond. So N triple bond. Like before, the first one we call it as sigma bond. The second one pi bond. And the third one pi bond. So here you have one sigma bond and two pi bond. Okay. So meaning that end to end is one side to side, another one side to side. Okay. So to form pi bond, you must have parallel orbital.